Question 10. In this question, we are asked to take the equation x squared minus 8x minus 29, and in fact it's not an equation, it's an identity, because you've got the triple equal sign there, and we're not actually asked to do anything with it. We're told that it's always, no matter what value of x, equal to this expression. Now I'm really hoping that you'll recognise the completed square form that we've got there. What we are asked to do is to find the value of a and b. So this is a variant on the give your answer in this form question. The form is given and we have to find out a and b. This is one where we are actually required to state the values of a and b at the end. So what I need to do is rearrange this into this form so I can see what a and b are. Given that this is the completed square form, I therefore need to complete the square on this here. Completing the square when we've got no coefficient on x squared is a little easier. Maybe in another video we'll see what happens when there's a coefficient on the x squared term. We have to halve the coefficient of x, but then we have to subtract the square of this. Not forgetting we're still having minus 29 at the end. Now, this line of working is identical to the line above, mathematically, so I'll make a note of that there. I now need to evaluate this and tidy it up a little bit because it's asked for b as an integer, not as a big mess here. So, keeping the bracket the same, that bit's fine. We can see already that a is minus 4. Here, if I have minus 4 squared, that'll give me 16, so I'm subtracting 16, and then subtracting 29. And for my final move to tidy that up, I have that x minus 4 all squared minus 45. And a is equal to minus 4, b is equal to minus 45. In this question, we were told to find the values of a and b, so we must state them. I tend to do that anyway. So, on to part B. In part B, we are told that x squared minus 8x minus 29, that's the expression from the part A. We're told now that it equals 0. And it says, hence or otherwise, so using what we knew in part A, show the roots of this are equal to c plus or minus d root 5. So this is the form that we're aiming for our roots of this. We were given this expression in the first part, and we were able to rewrite it in the completed square form. It says hence in the question, so I'm going to use what we've done already. These two expressions are equal, and since this one equals 0, so will this one. This is much easier for me to solve than that. Having been factorised using the completed square method, I can now go about solving it. If I was to add 45 to both sides of the equation, I would get here. Square rooting both sides, but remembering that when you square root you get a positive and a negative, and you can see that we'll need that in the completed answer. We get here. And adding 4 to both sides, brings me here. Now you might be tempted to stop, but let's check the format. It's root 5, not root 45, and there's a coefficient d, which we don't yet have. So there's a little bit more work to do, and we need to use our knowledge of surds to split this 45 into two surds. Now the form tells us that one of them must be 5 and the other one is 9, and as we'd suspect, it's a square number. Since it's a square number, we can evaluate it and get an answer that fits. In this question, C is 4 and D is 3. And that's part B completed. If these videos are helpful, please do subscribe so you can get updates when future ones are released. Also, feel free to comment if you have any questions below, and I'll hopefully be able to get back to you with further explanation if anything's needed. Thanks.